Hey, hi, welcome to my lesson. I'm excited about this today because this is the big one, solving equations. Alrighty. Solving EQS, equations. Okay. The majority of algebra revolves around being able to do this. We're going to start easy with linear equations, and then when you get more advanced, you're going to go up to quadratic, you're going to go up to cubic, you're going to go up to exponential. Oh, the sky's the limit. It's fantastic. Okay, so let's look at an example, e.g., alright, to explain the idea behind it. X plus 5 equals 9. Now, I know a lot of you are looking at this, and if I say, well, what's the value of x? You can go, well, what plus 5 gives me 9? 4. 4 plus 5 gives me 9. How do I know that? Because I just know it. I know 4 and 5 are 9. Well, that's all very good and well for something very simple like this. But when I give you something a little bit more complicated, how about 1.5x minus 3 divided by 14 equals 23? And I say, okay, well, how much is x? You go, I can't guess that. No, you can't. You need an algorithm to be able to solve that. Okay? You need to be able to unpeel the things that are happening to x in order to get into what is it at the center. Okay, so the understanding behind this is this. If I want to figure out what x is, well, I got to get x alone. So I got to get rid of the plus 5. If I take 5 away from plus 5, well, I have to be fair and do the same on the other side. I have to take the 5 away on the other side. Well, if I get rid of 5 here, I've just got x. If I get rid of 5 there, I've got 4 left over, which is great. Works really straightforward for simple stuff like this. But my kids used to come to me with like 3 and 4 step equations saying, "Sir, I don't know what to get rid of first." So I did some research, and I looked at all the equations, and I kind of simplified it to 2 words. Okay? And the 2 words are this. The first word, to decide what to get rid of first, is I reverse BIDMAS backwards. Okay? And then in order to actually do that, in order to get rid of the BIDMAS, I do the opposite to the other side. The opposite to the other side. So that means, if I'm looking at this, I say, what's happening to x? It's being added 5. Well, what's the opposite of plus 5? Minus 5. X equals opposite to other side. The 9 stays there, minus 5. Okay? Plus 5, minus 5. X equals 9 minus 5 is 4. Done. Okay. Your logic is perfect. Your layout is beautiful. Alright? There's no like arrows and saying I'm going here and I'm going there, I'm adding this. And the brilliant thing is that these 2 ideas, or this one idea, 2 words, can be used to solve that big monster that I put up over here. Give it a shot. Go back. Okay. So, let's look at another equation to show you how this works. E.g. Alright, a divided by 3 equals 6. Right, what's happening to a? It's being divided by 3. OTOS. Opposite of divided by 3 is times by 3. A equals 6 times 3. A equals 18. Done. Alright. You with me? It's as easy as opposite to other side. Okay. Let's try another one. 4x plus 3 equals 31. So this is EG3. EG3. 4x plus 3 equals 31. Okay, so now I'm getting into more, this is more of what you're going to be seeing. Year 7, Year 8, easy stuff, Year 9, okay? This is more what you're going to be seeing. Year 10, you're going to be graphing things, which you're going to be using this skill in. Year 9 as well. Year 11, this should be old hat for you. Okay, so 4x plus 3 equals 31. So what's happening to x? Well, he's being times by 4, and then we're adding 3 onto that. So I have to reverse the order of operations. So if I reverse BIDMAS backwards, opposite of plus, I've got to get rid of additional subtraction first. So we got 4x, you're going to stay there, he's going to stay there, equals opposite of plus 3 is minus 3. 31 minus 3. So 4x, he still stays there, 31 minus 3 is 28. Are you with me? Now, I've got rid of that plus, now let's get rid of the times. Opposite of times by 4, divided by 4. X equals 28 divided by 4. X equals 28 divided by 4 is 7. I almost said 14. I'm thinking 14, and I'm having fun. It's actually 7. Okay, 28 divided by 4 is 7. Alrighty, so there you go. Opposite to other side, reversing BIDMAS, out it pops. Okay, let's try a couple more. Righty. So, let's take a look at this one. 3x minus 5 equals 13, e.g. 4. 3x minus 5 equals 13. So what's happening to x? Being times by 3, then we're minusing 5. So let's reverse the order of operations. 3x equals, I'm going to skip a couple of steps here to show you the minimum layout. 13 plus 5, opposite of minus 5 is plus 5, is 18. Okay? Now, after times by 3 is divided by 3. X equals 18 divided by 3 is 6. This is, as far as I'm concerned, the bare minimum. The bare minimum. You can put in your working lines here. You can put in x equals 13 plus 5, x equals 18 divided by 3. You can put that in, okay? And I would suggest until you get comfortable that you do put that in. But when you start getting good at this, you go, okay, well, there's one move, boom, there's the answer. There's the other move, boom, there's the answer, okay? Okay, you are flowing with it. You're getting used to it, okay? That's why we practice, by the way, in order to make it second nature. Okay, so let's look at another example, e.g. Next one, 2x plus 6 equals 30. 2x plus 6 equals 30. Alright, so freeze the video. Pause the video. There's new modern technology. Pause the video and give this one a shot, okay? I'm going to just carry on from here. So, let's speed things up. I'm going to reverse bitmaps, get rid of the plus before the multiplication. So I've got 2x equals 30 minus 6 is 24. Opposite times by 2 is divided by 2. X equals 24 divided by 2 is 12. Okay, easy cake, huh? Last example. E.g. Okay? Now I've put this example in specifically for two reasons. 12 minus 2b equals 18. 18, yeah. Okay. Now the reason why I put this in is, number one, I put the letter second. Don't let that freak you out, okay? Remember, order of operations is more important than order of writing, okay? Unless I've just got plus or minus. But if you understand bitmaths really well, you'll get that. So order of operations is more important than order of writing. So if I say, well, what's happening to b here? Okay, it's not being times by 12 and then minus 2. It's being times by negative 2, and then, what's this? This is plus 12. There's no sign, it means plus. Okay, so it's being added 12 and times by negative 2. Okay, fantastic. So let's reverse bitmaths. Bitmaths backwards says get rid of plus or minus before multiplication or division. So I got that minus 2b, he's staying there, equals 18, opposite of plus 12, minus 12. So minus 2b equals 6. You with me? Alright. Now I'm going to break this down into two steps. I'm going to divide by the 2 first. You should actually divide by the negative 2. You should read this as minus 2. Okay? But I want to just quickly show you an idea that's happening here. The better way would be b equals negative 3. Done. But let's just look at this. So I've got minus, I'm going to divide by the 2. 6 divided by 2. Opposite times by 2 is minus 2. Opposite times by 2 is divided by 2. So I've got minus b equals 3. Now the reason why I did this is because I've seen a lot of kids get to this point. They go minus b equals 3, done. No, you're not done. Because minus b is not b by himself. It's negative b. What is b? Okay. So, this is why I've added this in. Is because whenever I don't have a number in front of a letter, I can always put in the invisible one that's hiding there. The invisible one that's hiding there. Okay. So to get b completely alone, not with a negative as well, b equals 3 divided by negative 1. That's the idea behind it. But you don't have to stress about that idea. You can just swap the sign. b equals negative 3. That is the answer. b equals negative 3. You're not finished when you get to this point, okay? Alright, please don't. It's a very common mistake that I see. Especially when you're first starting. People do this, all the way. What I would do when you get more advanced at this, well, not even when you get more advanced at this, you can start this from now, is divide 6 by negative 2. The sign is part of the number. Alright? Okay, I'm going to get into more complicated questions dealing with brackets, with x's on both sides, stuff like that, in future videos on other pages. Go check them out. Alright, and just remember, I'm here for you.